Question 16. Refer to the unbalanced equation when answering questions 16 and 17. In the balanced equation, the mole ratio for the sulfuric acid to water is. So what I've got to do is I've got to work out the numbers in front of the H2SO4 and the numbers in front of the water. And it'll either be 1, 4, 2, 1, 2, 4, 7 and 4, 9. Now you can put these numbers in 1 and 4 and work out whether it balances, but it's a bit of a long-winded way around it. Because if I look on the left, this H2SO4 is the only reactant with S in it. And on the right hand side I can work out how many S's I've got, and I can work out what this number is. So I've got Cr2SO4 in brackets 3. There's one S inside the brackets. The atoms inside the brackets are multiplied by the number outside. So there's one S inside multiplied by 3. I've got 3 S's there. K2SO4. There's 2 K's and 4 O's, but there's 1 S. 3 S's and 1 S is 4. So I've got 4 S's on the right hand side, and here on the left hand side S only appears in here, and there's 1 S in there now, so there must be 4 in front of the H2SO4. So I've automatically got a 4 in front of the H2SO4. In the balanced equation, the mole ratio for sulfuric acid to water, so I've got 4 sulfuric acid, so it must either be 4 to 7 or 4 to 9. Must either be C or D. So the question is, have I got 7 waters or I've got 9 waters? Well, now I've got 4 in front of here. I could work out, let's say, the H's. 3 2's are 6 H's, 4 2's are 8 H's, 6 add 8 is 14 H's. I've got 14 H's on the left hand side. Now I've got 4 here. How many H's I've got on the left hand side? Oh, well, the H's only appear in the water, so I must have 7 2's are 14. It must be 4 to 7. What is the reducing agent in this reaction? Now, a reducing agent causes something else to be reduced. So if something else is being reduced, the reducing agent is oxidized. So when something is reduced, something else is oxidized, because reduction is gain of electrons, oil rig, oxidation is loss, reduction is gain. So if something is being reduced and gained electrons, something's been oxidized to lose the electrons to give it to the thing that's been reduced and gaining electrons. So if something's been reduced, something's been oxidized, and the reducing agent causes something else to be reduced. It causes reduction, and in the process it is oxidized. So the question is, which of these are oxidized? So H plus is 1 plus oxidation state in there. What's it end up as? H2O. That's where it ends up. Oxygen's in group 6 of the periodic table gains 2 electrons, 2 minus oxidation state. No charge left over, so that's minus 2. The H's must be plus 1 each. Plus 1 and plus 1 makes plus 2. Minus 2 for the oxygen leaves no charge left over. So the H plus is not being oxidized or reduced. Let's have a look what oxidation state the C is in C2O4 2 minus. Oxygen's minus 2, so 4 minus 2 is minus 8, so the oxygens combined give minus 8. There's 2 minus left over, so the 2 C's must be plus 6 together. Plus 6 minus 8 leaves minus 2 left over. So the 2 C's altogether are plus 6. They must both be in plus 3. Plus 3, plus 3, minus 2, minus 2, minus 2, minus 2 leaves 2 minus left over. The C is in plus 3. What does it become? It becomes CO2. So what is it in CO2? Well, oxygen's a minus 2, no charge left over. 2 minus 2 is a minus 4, no charge left over. The carbon is in plus 4. So it's gone from oxidation state plus 3 up to plus 4. If it goes up in an oxidation state, it's been oxidized. It's gone plus 3 up to plus 4. It's been oxidized. It will cause something else to be reduced. C2O4 2 minus is the reducing agent because it's being oxidized. It's causing something else to be reduced. Answer B.